Right, so another statics problem. This time we've got 1, 2, 3, 4 forces acting about a point here, and we're assuming that everything's in equilibrium. So as a result of that, we want to work out F1 and this angle theta. We know that essentially we're going to combine this force, and this force, and they must result in a force that is equal and opposite to this force in order to sort of cancel this one out, and therefore for there to be zero resultant force. Okay, now the problem we've got is this one's acting on an angle, so we need to resolve it into vertical and horizontal components in order to then combine it with these forces here. Okay, so first thing, look at the vertical component of this 700 Newton force, and the horizontal component. Okay, so there's the horizontal component, ignore that, and there's the vertical component. Okay, so we've got a triangle here, vertical component, horizontal component of this 700 Newton force. Okay, so this vector and this vector head to tail, and this is the resultant of this vertical and horizontal component. Okay, so to work out the horizontal component here, this is going to be, well, it's the opposite, and this is the hypotenuse, this is the adjacent. This angle here is obviously 90 degrees, okay? So to work out that, we've got sine of 20 is equal to opposite over 700. So the opposite is equal to 700 sine 20, which equals 700 sine 20, 239, 239, and that's newtons. This component here is going to be basically 700 cos 20, using the idea that this is adjacent and hypotenuse. So 700 cos 20, and that gives us 658. So 658 newtons, okay? So we can now combine the horizontal forces. So we've got this horizontal force acting at this point now. If we redraw it, I suppose we've got 239 acting that way. Okay, and we can ignore this force now because we've resolved it into horizontal and vertical components. And then vertically up here, we've got a force of 658 newtons acting. So we've got 300 this way, 239 this way, 658 that way, 200 that way. So if we consider the vertical forces now, we're going to have 658 take away 200, which gives us a force of 458 acting vertically upwards. So that's 458 newtons. So that's just taking the 658, minusing the 200 because they're in opposite directions and they're vectors. Horizontally, we've got 300 acting this way, 239 that way. So if we take those two away, we get 61, and that is acting this way. Okay, so 61 this way. Whoops. So we've put 61. So we've put these two vectors head to tail, and then we can work out the resultant of those two vectors now. Okay, so if we draw a double arrow on there, that's resultant. Okay. Right, and what the key point here is, if this is that point there that we're considering, this resultant force here must be equal and opposite to F1, okay? So I know that's not very well drawn, but that should be on a straight line there. This resultant of these two vectors must be equal and opposite to F1 in order for those two to cancel out and there to be no resultant force on that point. So let's work this one out first, just Pythagoras. So we've got 458 squared plus 61 squared, then we square root all of that, and that's going to give us 462 newtons if you put that into the calculator. Okay, so we know that this is 462, and therefore we know that F1 is 462 newtons, obviously in the opposite direction. Now we're trying to work out this angle to the vertical, so this is theta, the angle to the vertical. We know that's going to be exactly the same as this angle here. Okay, because this is on a straight line. Remember, these two opposite forces are on a straight line. So this angle here, theta, is the same as that. So again, we've got opposite and adjacent. To work out that angle there, we're going to use tan theta. So tan of theta is equal to opposite over adjacent. Okay, and that means then that theta is equal to tan to the minus 1 of 61 over 4, 5, 8. And if you work that out, that gives you 7.59 degrees, or 7.6 degrees. Okay, there's that one done.